Hey everyone, it's Powell, and we're going to talk about factoring by grouping today. Now, factoring by grouping is usually done when you have a four-termed polynomial with a degree of 3. So a cubic polynomial with 4 terms. Usually. We'll see one later that doesn't. So in this setup here, we have 3x cubed plus 11x squared plus 6x plus 22. The first thing you always want to try and do before you factor is factor out the greatest common factor. If I look at this polynomial, there is no greatest common factor, so I'm not going to do it in this particular example. But factoring by grouping talks about taking each pair, so specifically looking at this pair of terms and the second pair of terms, and factoring out the GCF of each of those pairs. And you're going to kind of see what happens when we do that. So let's first look at this pair, 3x cubed plus 11x squared. Really the only GCF in that pair is x squared, so that's what I'm going to factor out. And what I've left behind is 3x plus 11. Now I'm going to look at this second pair, 6x plus 22. And the only common factor between those two terms is 2, so I'm going to factor out a 2. And wouldn't you know it, I have a 3x plus 11 left behind. So I have two terms, x squared times 3x plus 11 plus 2 times 3x plus 11. Now I'm going to factor out the greatest common factor of those two terms, which is the one in blue, 3x plus 11. So I'm going to factor out a 3x plus 11, and I'll have x squared plus 2 behind. And if that looks, oh, I forgot all my equal signs. That's not good. And if that looks a little weird, this middle step is what I would have if I took this 3x plus 11 and distributed it to those two terms, x squared plus 2. So it's weird to think of a binomial as a factor, but we are factoring out that binomial to the front, and we'll have a binomial left over. And if I look at the two terms I have left, they can't either be factored, so we're done with that one. So let's look at our second example. Again, we're going to look for a GCF. I don't see one. So we're just going to get right into looking at each pair. If I look at the first pair, x cubed plus 3x squared, again, my only common factor is x squared. And I have x plus 3 left over. But if I look at the second pair, negative x minus 3, I'm going to include the negative with that x. The common factor between those two is a negative 1. So I'm going to factor out a negative 1. And I have x plus 3. And as before, if I look at the two terms I have left, x squared times x plus 3 minus 1 times x plus 3, I'm going to factor out the x plus 3, and I have x squared minus 1 left over. And I factor out that common factor, the blue factor in this case. But we're not done yet, because if you look at what we have left, x plus 3 can't be factored anymore, but x squared minus 1, that's a difference of two squares. So x plus 3 and x squared minus 1 can be factored into x plus 1 times x minus 1. So be careful that when you're done, look and see if you have a difference of two squares left over. If you do, you can keep factoring until you are done. And that's why the directions say factor completely, because they want to make sure that you just always look at what you have left to see if it can be factored any further. And that's that one. And as you can see, when you get to solving polynomials, having these three terms set equal to 0 makes finding the solutions for that very easy. All right, let's look at our third example. 2x to the fourth plus 10x cubed plus 20x squared plus 100x. That should have an x on there. So, as I mentioned, factor by grouping is used mainly for four-term polynomials that are a degree of 3. Now, I don't have a degree of 3, I have a degree of 4. However, remember what I said in the first example, see if you could factor out a GCF, which I can. I can factor out a 2x. Every one of those shares a 2x. After I factor out the 2x, I have x cubed plus 5x squared plus 10x plus 50. And as you can see, when I factor out that 2x, I have a 4-termed cubic polynomial left over that we can factor, which we will do by grouping. So I look at the first group, that's an x squared, and I have x plus 5. I look at the second group, 10x plus 50. I take out a 10, and that's also an x plus 5. This 2x that we factored out at the beginning has to go along for the ride, and mostly because it's a factor of it. And inside those parentheses, I'm going to factor out an x plus 5. And I think we don't need that other set of parentheses. So I factor out the x plus 5 from those two terms, and I get x squared plus 10 left over. I should also mention that it's important to factor out the greatest common factor, not divide off the greatest common factor. If the greatest common factor is just a coefficient, so if it's just an integer, feel free to divide it off. But if that greatest common factor has an x or any variable involved, you have to factor it out, otherwise you'll lose one of your solutions when you solve. But that's our factorization of that 4-term, 4th degree polynomial that we turned into a 3rd degree. Now, at the beginning I said that factor by grouping is mainly used for 3rd degree polynomials. I said mainly because here's an example of a 6th degree polynomial that will also use factor by grouping. Now, it's hard to see that this would be factor by grouping, except that if we look at each pair, just for the heck of it, you can see that no pair has the same GCF or the same factor that would be left over if we factored anything out. So with factor by grouping, we're going to look at these terms, or these groups rather, to see if there's something that is left over that's common when we factor out a greatest common factor. So with the first trio, we have a 2y that we're going to factor out. And what we'd have left over if we factored out a 2y is a 3a, a 2b, and a minus c. If we look at the second trio, we have a greatest common factor of just z, so plus z. And we have a 3a plus a 2b minus a c. And as you can see, when I factor out each of those greatest common factors, I have the same thing left over. That wouldn't have happened if I looked at them pairwise, but if I looked at them trio-wise, I do have that same thing left over. And then we can factor out that 3a plus 2b minus c, and then we have 2y plus z. So these aren't common, but if you see a problem like this in the section of factor by grouping in your book, now you know that it is a factor by grouping. They're not just trying to pull a fast one on you. So if you like this video, please subscribe and share this with anybody that would benefit from this, and stay tuned for more videos on factoring. Thanks for watching.